Assalamualaikum. Hi guys. In this video, we are going to learn about anomalous electronic configuration. So what does it mean by anomalous term here? Anomalous usually bermaksud something yang abnormal ataupun something yang inconsistent daripada benda yang biasa kita buat. So that is how I want to explain based on electronic configuration. We know that we have to apply these three rules or principles when writing down the electronic configuration. However, there are certain elements in predict table where its electronic configuration do not obey the three rules. That is why we call that as anomalous electronic configuration. So apakah elemen yang tidak obey itu? Kita ada dua contoh. The first one is chromium and the second one is copper. So chromium and copper have electronic configurations which are inconsistent with Aufbau principle. So it does not obey Aufbau principle. But the anomalous electronic configuration for them are acceptable. So let's go to how it looks like. Element for chromium, we have 24 proton number. What we have is AR3D4 for S2. This is what we should predict because we are going to fill in for S2 and 3D4. However, the actual one should be AR4S1 3D5. So this is where you take out one electron from 4s to fill into 3D orbital to get 5. Next, we have copper with 29 electrons. So as predicted, it will be AR for S2 3D9. But actually, the real electronic configuration for copper will be AR 4S1 3D10, where we take one electron from 4s orbital, fill in into 3D orbital to make it as 10 electrons. So this anomalous configuration can be explained based on fully filled and half filled orbital. And fully filled or half filled orbital are more stable. So contohnya macam mana? Let's go to how does it looks like. Half filled orbital is referring to the condition where all 3D orbitals are filled with one single electron. You can see from here 3D5. Or if I want to write down another one based on 3p orbital, if I want to write as in half v orbital, I can write as 1, 1, 1. This is what I mean by half filled 3p orbital. So it's just the same thing. Next, we have another term, fully filled orbital, which is referring to the condition for all of 3D orbital are fully filled with electrons. For example, you can see 3D10. You got each room 2 electrons of it. So, untuk case when you have chromium and copper, is going to have its explanation for the electronic configuration based on these terms, half filled orbital or fully filled orbitals, because these orbitals are more stable. So if you see here for chromium, I have what predicted to be 18AR for S2 3D4. But actually, we are going to put the actual one as in 18AR for S1 3D5 because instead of leaving 4 electrons in the room for 3D subshell, we are going to make it as half filled orbital. So one electron is going to be taken out from here and put it into empty room for 3D subshell. So this is half filled d orbital which are more stable. Next, same goes for copper. We have predicted for copper which will be AR for S2 3D9. But instead of leaving one electron here without any couple, without its pair, I'm going to take out one of these from 4s orbital and put it here because it will provide extra stability to the 3D orbital. So this fully filled d orbital will be more stable. So based on the stability, so far you've learned 3 terms. I'm going to write it down for you for stability. We got the first one is fully filled orbital. The second one is half filled orbital. And I'm going to introduce to you another one more, which is partially filled orbital. So how does partially filled orbital looks like? For example, I have electronic configuration 1s2, 2s2, 2p2. So I can write it down as in orbital diagram like this one, with positive half, negative half, positive half, negative half, and then positive half, positive half. So you can see that partially filled maksudnya dia sama ada 2 elektron ataupun 1 elektron dalam 2p ni. Kita boleh cakap this 2p orbital is partially filled. Dia separuh isi. Dia bukan separuh isi tapi dia separuh isi. So these 3 terms, if you take a look carefully, we got different terms in terms of stability. So which one is the most stable? The most stable will be fully filled orbital. So the stability increases from partially filled, followed by half filled, followed by the last one, the most stable is fully filled. So later on, if we talk about the stability of the orbital, I hope you can understand there are 3 different terms for that. But usually we use these 2, but at least you know there is one more. So that's it for this video. I'll see you in the next one. Bye!